The next step we should consider taking in the design of our fixture is examining our indexing pin. First, we should consider the pin and the part hole at their LMC, least material condition. The smallest the pin can be is 0.4997 and the largest the hole can be is 0.5007, which means there's a 1/1000 difference in diameter or a possible radial gap if everything is perfectly on center of 1/2 thou. Since we already know that this is well within the acceptable tolerance, we can go ahead and start examining the pin for its function. If it were not, we would have to consider making a pin that would always self-center, so the pin would very likely be tapered. Upon examining the pin, one of the first things we tend to notice is there's a small 25 thou chamfer on the front. This is the first thing to enter the hole. A larger chamfer here would make an easier transition. So I'm going to go ahead and I'm going to double that to 50 thou. Next, if we look at this section view of the assembly, several things should pop out right away. The first one being, there's no clearance in the pin for the drill, and the pin will be hardened. Bringing the drill down into a hardened pin, that's typically bad. And once we add clearance to our pin, how do we keep it oriented so the drill always comes down into the clearance and not into the hardened pin material? Another issue is when the pin's retracted out of the part, what keeps it with the jig? It would be better if it wasn't lost or dropped under a machine or table. And if the pin is going to stay with the jig while we're loading and unloading the part, how do we ensure it stays out of the way? First, let's figure out how to add clearance for the drill. The clearance hole will need to be a larger diameter than the drill diameter of 0.257. We also have to think about how deep do we take the clearance. Well, the length of the drill point is 0.3 times its diameter, so we have to make sure we go more than 0.0771 deep. To ensure the drill doesn't hit the pin, I'm going to add a 150 thou deep cut, 0.625 from the end, as shown here. I'll also be certain to add a standard fillet size, in this case 1/32, so that there's no square corner to crack during the heat treatment process. Next, I need to ensure the pin is always in this orientation so the drill never hits it. To ensure the proper orientation of the pin, a small flat would be added to the opposite side as shown here, and then a set screw to maintain the orientation. Next, a solution needs to be found to prevent the pin from being removed during loading and unloading of the part, so it cannot be lost. To solve this problem, the flat on the bottom is altered so that the pin cannot be removed unless the set screw has been removed first. Next, a method needs to be found to keep the pin out of the way while loading and unloading of the part. To ensure the pin stays out of the way when loading, a simple part such as this could be added, which rotates around a set screw. When out of the way, it could lean against this screw here, and when needed, it could be rotated down into place to prevent the pin from being pushed into the part. The solution shown here is just one of many possibilities. Another common solution is to add a spring around the pin, and the pin would need to be held into place until the part is tightened, and then as soon as the pin is released, it's retracted out of the way.